2025, February, March, paper 42. Okay, so let's take a look at the first questions. Question number 1. We have a diagram over here. 3 coplanar forces of magnitude 40 Newton, 30 Newton, and X Newton act at a point over here in the direction shown in the diagram. Given that the forces are in equilibrium, find the values of the theta and x. So what we need to do is we resolve the forces vertically. Then we will get the 30 is equal to the x sine theta. Okay, and we also need to resolve the forces horizontally. So if I resolve the forces horizontally, I get the x cos theta is equals to the 40 Newton. So over here, maybe I just write this as a x sine theta in front is equal to 30. I call this one equation number 1. I call this one equation number 2. So we want to find the value theta. To find the value theta, just take the equation 1 divided by equation 2. Then you will get the tangent theta is equals to the 30 divided by 40. So from here, we can find that the theta is arctangent of 3/4. Just use calculator, you will get 36.9 degrees. Just like that, done for the theta. We now need to find the x. So to find the x, we can just take the number 1 square plus the number 2 square. So if you square the number 1 and you square the number 2, you get x square sine square theta plus the x square cos square theta. You will get 30 square plus the 40 square. So you can see that if you factorize it out, inside here is a sine square plus cos square. Sine square plus cos square is a 1. So you get this one as the 2,500. And square it, you get 50 Newton. Okay, so this will be the answer for the question number 1. Done. Now we move on to question number 2. Is traveling along a straight horizontal road at a speed of 40 meters per second. When he passes a point O, she accelerates at a constant rate of the distance of 42 meters, reaching the speed v meter per second. She maintained the speed v meter per second for 50 meters and then decelerate 2 meters per second square before come to rest. The distance traveled while decelerating is 16 minutes. Okay, find the value of v. So over here, actually, there are a few ways to solve it, but usually I prefer to build the VT graph. I build the VT graph, easier for me to interpret the situations. So it's up to you. You don't have to follow my method if you don't want to. So first of all, when it passes the point O, the speed is 4 meters per second. Then you decelerate, you accelerate until you reach the speed v. This is the first stage. The first stage, the total distance is 42 meters. Then after that, you maintain this speed for a while in order to travel for 50 meters. Then after that, you start to decelerate until you come to rest. This is 16 meters. Now they're telling you that these decelerations is a negative 2 meters per second. The A is a negative 2 meters per second square because it's decelerations. Okay, so this is what we have. So now what you can do is that from the diagram, we will focus on this portion only. Because this portion is in, they give you the accelerations, they give you the decelerations, but whereas the first two sessions, the first two stages, they didn't give you the decelerations. So what we can do is that we will apply this formula v square equal to the u square plus 2as for the stage number 3. So I get the 0 square is equal to the v square plus the 2 of a negative 2. The distance traveled is a 16. So you can get the v is equals to the square root of 64. You get 8. That is the answer for the part A. Done. Okay, now we move on to the part B. Find the total time for which she is in motion from the instant that she passes through O. So we want to find the total time. That means we want to find the total time, how much from here to here. Since we already know the V is an egg, okay, so maybe we can just copy and paste the diagram that I draw just now over here to explain further. So this is a 4. We know the V is 8 now. So this is what we have. This is a 42 meter, 50 meter, and 16 meter. Okay. You do not need to provide me this diagram in exam over here for the part B because actually just use back the diagram in the part A that I draw just now will do. So over here we can say that the total distance travel is equal to the total area of the graph. Again, this one is you actually no need to write down this relationship. So the total distance travel is 42 plus 50 plus 16. What is the first stage graph? The first stage graph is a trapezium, so it's a half multiplied by I call this one D1, D2, and D3. Okay, D1, D2, D3. So the first stage, D1. Okay, I think we do stage by stage. My apologies. I do stage by stage. It's easier to get the D1, D2, and D3. So if we do it all together, that will be more troublesome. So we do stage by stage. Stage 1. So the S1 is equal to 42. This will be the area of trapezium. Half times the A plus B multiplied T1. So you will get your T1 is equals to the 72 divided 6, 7 seconds. Okay, so now stage number 2. Stage number 2, your S2 is equal to 50. This is the area of a rectangle. Area of rectangle, it will be 8 multiplied T2 minus the T1 is equal to 50. We are focusing on this stage right now. So the area, the shape over here is a rectangle. So the area of rectangle formula. So we already know that D1 is a 7. This one is a 50 over 8. So you can find that the D2 is a 7 plus 50 over 8. So you get 13.25. That is your D2. Then now stage 3. Okay, so for stage 3, the area here is a triangle. So it's a triangle shape. So what you need to do is S3 is equal to 16. Half times the base times the height is equal to 16. So the D3 minus the D2 is equal to 4. So your D3 is a 17.25. Done. This will be the answer for the number 2. Okay, so now we move on to question number 3. Speed. The aeroplane is flying horizontally and the aeroplane engines is producing a constant power of 5,500 kilowatts. And the airplane experiences a constant horizontal resistance force of 25,000 Newton. So if you resolve the forces horizontally, you will see that you have a driving force minus the resistant force is equal to the MA. But because of constant speed, the A will be 0. So you get FD is equal to the FR. I just mentioned that it's a constant speed. So your driving force, because we know that the power is equal to the FV, the driving force will be the power over the V. Okay, so we just take the power divided by V is equal to the FR. The power is given as 5,500 kilowatt divided by the speed and is equal to the resistant force, 25,000. So your V will be taking the 5,500 kilowatt divided by 25,000. So you will get the answer as 220 meter per second by using calculator. So this will be the answer for the part A. Now we're moving to the question B. The aeroplane had then ascend 300 meter in 50 seconds. Okay, 300 meter in 50 seconds. While maintaining the same speed, the resistant force, the same speed. Resistant force is no longer constant, and the work done against the resistant force is ascend in 300 meter is 270,000 kilojoule. The mass of the aeroplane is 60,000 kilogram. Find the average power of the aeroplane's engine. So what we need to do is, you can see that at here to here, you have going up 300 meter. Okay, but they didn't mention you're going up in the straight line, or you're going up like this, or you're going up like this. So actually, we do not need to know the half. We just know that you have going up 300 meter. So over here, these questions, obviously, we need to use a conservation of energy. So we just use COE. We have the GPE gain, okay, the potential energy gain, gravitational potential energy gain, and then you have the work done by the resistance also gain is equal to the work done by the driving force. Okay, so this is what we have. Now, GPE is MGH. Work done by the resistance is the resistant force multiplied by the distance travel, but actually no need, because they already give you this as the 270,000 kilojoule. Okay, so this one is already given. Now the thing is that, how do you find the work done of the driving force? The work done of the driving force, we know that the work done, the formula of work done for driving force is the driving force multiplied by the distance that you travel. Okay, but we know that the force is actually P over V. Okay, so P over V. So we can see that we can actually make this become P S over V. So what is S over V? We know that S is equal to the VT. So the T is equal to the S over V. So we can just write PT. Okay, so this is what we can do. Power multiplied by time. So this one is a P multiplied by time. So now what should we do? We just need to put in the value. Your M is 60,000. Your G is 10. Your height is 300. Your work done by the resistance is given 270,000 kilojoule plus the power. Not enough place for me to write down the power. So the power is 5,500 kilowatt. multiplied by 50. The time is the 50. Hey, sorry, I make a mistake. They say the power change. The power have changed. Okay, the power change. Okay, but because I still using the power over here. Okay, so I make a mistake. My apologies on that. So this one is actually just PT. So the PT will be 50p. 50p. Sorry about that. So now press the calculator. Just use the calculator directly. Press it. You can see that you get the answer as 9,000 kilowatt. Okay, I just make it become kilowatt because if I write in terms of watt, it will be too many zeros over here. So the answer will be 9,000 kilowatts. So done. This will be the answer for the question B. So now we move on to question number 4. Question number 4. We have a diagram over here. Two particles A and B have masses of 0.3 kg and 0.1 kg respectively. The particles are attached to the end of a light inextensible string. The string passes over a smooth pulley and the particle hangs vertically below the pulley. Both particles are initially at a height of x meter above the horizontal ground. The system is released from rest. Find the tension in the string and the accelerations of the particle. So we know that these two tension must be the same because it's the same string and it passes over a fixed smooth pulley. So what we can do over here is that we resolve the forces. At A, the particle A is heavier, so it will be the weight 3 Newton minus the tension is equal to the 0.38. That will be my equation number 1. At B, it will be the D minus the 1 Newton is equal to the 0.1A. That will be your second equations. Take the equation number 1 plus with the equation number 2, you will get this as a 2 is equal to 0.48. So by pressing the calculator, you can see that your A is actually 5 meter per second square. So if you put it back into the equation 2 or equation 1, over here I put back into the equation 1, I get the D is equal to the 1 plus the 0.1A. So I get this as a 1.5 Newton. That will be the tension of the string and the acceleration of the string in part A. So we are done. Now we move to the part B. During the subsequent motion, B does not reach the pulley. When A reaches the ground, it comes to rest. Okay. So when A reaches the ground, okay. So this is the original positions. Okay. So maybe I put it over here. This is your original positions. This is the ground. So that means the B is over here right now. Okay, the B is over here right now. So this is the and the A right before it hits the ground. Okay, right before it hits the ground. Okay, so this one is the stage number 1. So I need to find the speed over here because they are sharing the same speed. Okay, they are sharing the same speed. So we just need to take the formula v squared equal to the u squared plus 2as. So your u is a 0 because you release from rest. Your A just now, the A from part A was 5 meter per second square. Then the height is because this just now your original position is your height is x meter. Your height is x meter. Yeah. So your v square is equal to the 10x. That will give you that the v is equal to the square root of 10x. Okay. Then the stage number 2. Because after A hits the ground, there's no more tension. Okay. Yeah, the string becomes slack. The string becomes slack. No more tension. Okay. Then the B continue to move up by depending on the gravitational force. Okay, so this one, the B continue to move up. This one no more tension. Okay, this one no more tension. So no more tension. We will consider at B, the W square is equal to the V square plus 2AH. Okay, so your W square, because you want to calculate the maximum height. Maximum height, that means your B have to reach until the W equal to 0. So 0 square is equal to the V square is over here. This is a 10x. You are moving under free fall condition. It will be a negative 10. Your A will be a negative G meter per second square or negative 10 meter per second square. Your height, you do not know the height. So just use your calculator. You can see that your height is actually 10x over 20 is a half x. Okay, so this is what you have. So your total height, maximum height. Okay, reached by B. Is equals to 1.2 meter. Okay, maximum height reached by B is 1.2 meter. Because in the stage 1, the B have moved up x and x. So in the stage 1, B already moved up 2x. So 2x plus the half x is equal to the 1.2 meter. So add together, you get a 5 over 2x is equal to the 1.2 meter. So your x is a 2.4 over 5. 2.4 over 5, that will give you 0.48 meter. So done. This will be the answer for the question number 4B. Okay. So now we move on to question number 5. Because over here, PQ and R measure 0.6 kg, 0.4 kg, and 0.8 kg respectively. They are at rest in the straight line on a smooth horizontal plane. The distance from P to Q is 3 meter, and the distance from Q to R is also 3 meter. Okay, P is projected directly towards Q with a speed of 3 meter per second. Okay, after P collide, P and Q collide, P continue to move in the same directions with the speed of 1.5 meter per second. So we want to find the speed of Q after the first collision. So the collision between P and Q, the collision between P and Q is before and after. So this one is a 0.6 kg and 0.4 kg. So over here, I draw the circle bigger. 0.6 kg collide with the 0.4 kg. Before, this one is a 3 meter per second. This one is 0. After that, this one is a VQ. This one is the 1.5 meter per second. So by using the PCLM, principle of conservation of linear momentum, so you will have the 0.6 multiplied by 3 is equal to the 1.5, 0.6 multiplied 1.5 plus the 0.4 VQ. Press the calculator, you can find that the VQ is 9 over 4 meter per second. So this is the answer for part A, just like that, done. Okay, so now we move on to the part B. In the subsequent motion between Q and R, these particles coalesce. Find the speed of the combined particle after the collision. So between Q and R. So Q and R, so Q is a 0.4 kg. R is a 0.8 kg. So because after Q collide with the P, Q is moving with the speed just now in part A, we know that is a 9 over 4 meter per second. This one is at rest. Then after they combine, we are having W. Okay, we are having W. So again, we're using PCLM, Principle of Conservation of Linear Momentum. 0.4 multiplied by 9/4 is equals to the 0.4 plus the 0.8 of W. So your W, just press the calculator, you can get this one as a 0.75 second. So this will be the answer for the part B. Okay, so now we want to go for part C. Find the time that it takes from P is initially projected until the instant at which P collide with the combined particle. Oh, okay. So we need to separate them into several stages. This is the stage 1. This is the stage 1. This is the stage 2. And the stage 3 is where the P and the combined particle collide. Okay, so we consider stage 1. So P and Q. We are looking for time. So what is the time taken for P reach to Q when the P and Q collide? Okay, P and Q collide. So because in the stage 1, your P moving over here, the distance is 3 meters. Okay, so we just calculate. Stage 1 is that the 3 meters per second multiplied by the time is 3 meters. So your T1 is 1 second. Then stage 2, Q and R. So when the Q and R collide, okay, Q is moving with the speed of 9/4 and the time is T2. The distance is also 3. Then you can get your T2 is actually 4/3 meters per second. 4/3 seconds, sorry. Okay. Now, at the same time, what is the P has traveled? Okay, at the same time, what is the distance that the P has traveled? So the P just now already traveled 3 meters, right? But after Q start to move, the P is still continue moving, but with a speed of 1.5 meters per second. So the Q move this much of time. The P is also moving at the same time, 4/3 seconds. So at the same time, P is moving how many distance? Okay, so we just say that the P is the distance traveled by P. Is equals to the 1.5 multiplied 4/3 seconds. Okay, so if you calculate this, you can see that the distance traveled by P is 2 meters. Okay, so 2 meters, 1 meter, 3 meters plus 2 meters, already 5 meters. Okay, so that means when the Q and R collide, when the Q and R combine together, the P is here. And from the beginning until here, the P has traveled total of 5 meters. And the time has passed 1 plus 4/3 seconds. Okay, so this is the what is P experiencing. So now the distance between them is still have 1 meter left. Still have 1 meter left. Okay, so now the speed over here is W. W that we found just now is 0.75 meters per second. The P is still moving with the speed of 1.5 meters per second. So how are we going to collide again? Okay, so what we need to do now is to calculate, okay, stage number 3. We're going for stage number 3 right now. What is your displacement of P? Displacement of P, I will be using this formula, ut plus half at squared. Because it's moving with a constant speed, the floor is smooth, so it will be having no acceleration, no deceleration. You're having constant speed, and the constant speed will be the 1.5 t. What will be the combined particle Q plus R? The combined particle is also the ut plus half at squared. So the speed that they give you is not u, actually is a w. Okay, w is 0.75 t. Okay. But the combined particle is actually 1 meter ahead of the P. So you just need to write it like this. So when they collide, SP and the SQ plus R are the same. So we have a 1.5 T is equal to 0.75 T plus 1. At the end, you solve it, you can see that your T, it will be equals to 4/3. Okay, this is the D3. This is the D3. Yeah. So therefore, the total time is equal to the D1 plus D2 plus D3 is equal to the 1 plus 4/3 plus 4/3. You get the total time of 11/3 seconds. Done. This will be the answer for the question number 5. Okay. So now we move on to question number 6. Let's take a look at question number 6. We have a block of mass 12 kg placed on a rough inclined plane at an angle of alpha to the horizontal. Rough plane, that means we have frictional force, where the alpha is equal to the arctangent of 0.5, a force of x Newton applied on the block directly up the plane. The coefficient of friction between the block and the plane is mu. Given that the mu is equal to 0.15 and the x is equal to 20, find the time it takes for the block to move 2 meters down the plane from rest. Okay. So over here, first of all, we need to focus on this one first. Your alpha is, okay, I think we can write below here. Alpha is the arctangent of 0.5. That means the tangent alpha is a half. We will build a small right angle triangle over here. Using the Pythagoras theorem, you can get this. So I don't want to find the decimal value of the alpha. I want to find the exact value of the alpha. So this is what I usually will do. So now I will redraw again the diagram. I will treat the block as a dot. And this is the plane. This is your normal contact force. This is your weight. Your weight is a 120 Newton. And this is your alpha. This is your x. And they say x is over here. For this case, x is a 20 Newton. And you are moving down. So if you're moving down, that means your frictional force must go in this way. Your frictional force must go in this way. Okay. So this is not equilibrium. If you resolve the forces this way, you can see that your R is equal to the 120 cos alpha. By using the diagram over here, you can see that your cos alpha is 2/35. So it will be 240/35 Newton. And since you're moving, your frictional force will be reaching the maximum frictional force, mu R. Mu R is a 0.15 multiplied by R. So over here, we can press the calculator. You can get 36/35 Newton. for your frictional force. Okay, now I resolve parallel to the plane, then it will be the mg sine alpha minus the x minus the fr is equal to ma. So what is your m? 100. M is a 12, g is a 10, sine alpha also refer to the small triangle, triangle, minus the x is 20, minus the fr, we have just found xr. What is the m? M is 12. So over here, just by pressing the calculator, then you can get the answer. So over here, I will leave my answer in exact value form. It will be 21/5 minus the 25 over the 15. But the question didn't mention that the answer must be in exact value form. You can press the calculator by giving the answer in decimal if you want. So this one, you can press it yourself. Okay, you can press it yourself. 21/5 minus the 25 divided by 15. So it's 1.46. Correct to, or maybe we can write extra 3 more significant figure, make it 5 significant figure, and I rounded it up to become 3 significant figure. Okay, so that will be the answer for the part A. Done. Oh, sorry, haven't done yet because they're looking for time. They're looking for time. Okay, so after we found the accelerations, then the time taken is s is equals to the ut plus half at squared. So your distance travel is 2 meters. Your u is start from rest. Then your a just now we found is a 1.4638. The time you do not know. Over here, now you press a calculator. Now you can get the time is 1.65 seconds. So that will be the answer for the question number 6A. Okay, so now we move on to the question number 6B. It is given that instead the mu is not equal to the 0.15, but the x now is 10 meters. The block is at the point of moving down. At the point of moving down, that means it's limiting equilibrium. Limiting equilibrium. Find the value of mu and the value of x for which the block is at the point of moving up. Find the value of the mu and the value of the x which the block is moving up. Okay, so when x is equal to 10, okay, so if you want, you can redraw again the diagram. Okay, if you want, you can redraw again the diagram. You have a x is equal to 10 here, and you are in the point of moving down. That means your frictional force will be going up. This will be your weight, 120 Newton. This is your alpha. So if you do it this way, your R, actually your R still same lah. Your R still same like just now. So we actually just copy down the answer we'll do lah. Your R will be this. Then your FR will be this. So there's no changes of the normal contact force and the frictional force. Okay. So if you going this way, now this time it will be the mg sine alpha is equal to the x plus the fr, because now you are having limiting equilibrium. So it will be 120 of sine alpha is equal to x plus the fr. Oh, sorry. I make a mistake. The FR is no longer 0.15. I missed out this information. So this one is a mu R. Mu R, it will be 240 mu over Z5. So this one, the FR will be 240 mu over Z5. Okay, so over here, we can just press a calculator. Press a calculator, you can get your mu. Since the Exact form is not so nice. You can just leave the answer in decimal place. I leave it in the 5 significant figure form. Then I round up, become 3 significant figure over here. So this will be my coefficient of frictions, 0.407. Okay. Then after that, haven't finished yet because now we are considering the case when now we want to find that the value of x so that the block is at the point of moving up, So another situations, your x is over here, your r is over here. This is your alpha. Your frictional force this time is going this way because you're at the point of going up already. So over here, your actually your R still same. 245. And then your FR. FR is this. 240 mu over 35. So maybe we can change it. We can actually replace the mu inside here. But I think I'll do it later. Okay. So if I resolve the forces this way, I will have that the mg psi alpha plus the FR is equal to x. So your x will be equal to the 120 psi alpha plus the mu, 200 FR is a 240 mu, 0.40683 divided by 35. So just press a calculator and everything carefully. You'll get the answer of x as a 97.3 Newton. Okay, so this is done. So this is how you get the answer for the question number B. So this one had to be careful, because the mu have changed. So we have to change accordingly. Okay, so the FR, we have to recalculate the FR. Okay, so now we move on to the question number 7. Particle move in a straight line. The velocity v meter per second of a particle t second after leaving a fixed point O is given by these equations. Where the k and p are constant, the accelerations of the particle at t equal to 1 is 42 meter per second squared. And the displacement of the particle from O at t equal to 1 is 93 meter. Show that the k is equal to 3 and the p is equal to 26. So this one, you can see, obviously, this one, the acceleration is a variable acceleration. So we need to use differentiation and integration to solve the problem. Okay, so the question telling you that acceleration. So for acceleration, we just need to find dv dt. Just differentiate, you get p minus the 12t. Then when the d is equals to 1, your A is equals to 42. That is your A. So you just put A 1 inside, you get B minus 12 is equal to 42. I call this one equation 1. Then now this one is displacement. So displacement, you have to integrate. Integrate the V. Okay, so you get K of 20t plus the pt square over 2 minus the 2t cube. Plus C. Okay, this one we have. Then when t equal to 0, s equal to 0. That will give you the C is also equal to 0. How do we know that? Because they say that it's passing through a fixed point O, t second after leaving a fixed point O. So that means the t equal to 0, s equal to 0. That is the meaning. Okay, so from here you can see that the C is also 0. So that means now S is equal to the K over 20t plus the bt square over 2 minus the 2t cube. Then when the t is equal to 1, your displacement is 93. Right? S is equal to 93. So your 93 is equal to the K of the 20 plus the B over 2 minus 2. You get this as the 18, 36 plus B over 2. That will be my second equations. Okay, so I will take the first equations divided by equation number 2. Then I get 42 divided by 93 is equal to the K of the B minus 2 divided by the K of the 36 plus B over 2. Cancel the K. So you will solve it, the relationship. Sorry, it's B minus 12, not B minus 2. This is a B minus 12. So over here, we can simplify it so that we can get this as the 36 plus B over the 2 of the B minus 12 is equal to the 93 over 42. So simplify it again. Cross multiplication, actually just do cross multiplication. You get 756 plus the 42p is equal to the 93p minus the 1116. Sorry. So geez, typing error, right wrongly. It's a 21p, not 42p. Wait, press the calculator wrongly. So this one is 756 plus 21p is equal to the 93p minus 1116. Okay, simplify it, you will get the p is equal to 26. So since the p is equal to 26, you can just put back in the equation 1 or equation 2, that is up to you. I think I will put back into the equation 1. Equation 1 is a 42 equal to the k of the b minus 12. So it will give you that the k is equals to 3. So we have shown that the k is 3, b is equal to 26. Shown. Okay, so this is the answer for the question number 7a. Okay, so now with these two values, b is 3, k is 26, we want to use this value and moving on to solve the part b. Find the distance moved by the particle between the time which the acceleration is 0. So now my v this time is 3 multiplied 20 plus the 2060 minus the 60 square. Okay, my A is a 3 of the 26 minus a 12d. So they mentioned that acceleration equal to 0. A equal to 0. That will give you 26 minus 12d equal to 0. Your d is 13 over 6. Okay. So v is equal to 0. V is equal to 0. That means 20 plus 2060 minus a 60 square is equal to 0. We just make this equal to 0. So you will be having 3t square minus a 13t plus minus 10. So you get the t is equal to negative 2 over 3 and the t is equal to 5. So you have to ignore the negative value of t. So we need to find that in between these two values, the distance travel. Okay, the distance travel between these two values. So over here, your distance travel, it will be just straight away integrate from 13 over 6 to 5 VDD. So the VDD, I think I can just straight away write my V as the 3 and then 20 plus 2060 minus the 60 square. DT, straight away integrate. So over here, I take the 3 out. Here I get 20t plus the 13t square minus the 2t cube. So what you need to do is just carefully substitute the value inside and press a calculator. So over here, this one is nothing tricky. Just have to be careful only. So you have a 100 plus the 325 minus the 250 minus this one is the 130 over 3 plus the 2197 over 6 over 36 minus the 2197 over the 108. Press everything using your calculator. You will get the answer as 172 in 3 significant figure. Okay, you can leave the answer in the fractional form, okay, or you can just leave the answer in round it up to 3 significant figure. That is up to you. Okay, you can actually give the answer in terms of fractions. 4913 divided by 18. Okay, so it's up to you, exact value. Decimal, it's up to you because the question, they didn't specifically mention they want in significant form or 3 significant figure form or exact value form. So either one of the answer is fine. So done. This will be the answer for question number 7, and this will be the last question for this paper. So over here, I will stop the video here. I'll see you next time. Bye-bye.